A man is sitting in a cafe. He types a message to his wife, reached safely. He presses send. But before the message travels even 1 centimeter across the internet, it shatters into thousands of pieces, rearranges itself into unreadable symbols, transforms into a secret code that even the cafe's hacker, sitting just 3 tables away, cannot understand. The hacker captures the message. He smiles. He opens it. And all he sees is 7F9A hashmark 4C2X9P1. Useless, meaningless, because the real message is locked behind a digital key he does not have. That invisible transformation, that silent protection, that magical shield is encryption. And today, in this module of Knowitrix, you will understand exactly how it works, not with complicated math, not with confusing jargon, but with real-world analogies, simple visuals, and stories that make encryption unforgettable. What is encryption? Explained like you're 10 years old. Imagine you want to send a letter to your friend, but the road between your house and your friend's house is full of thieves. If you send the letter normally, anyone can open it, read it, copy it, or change it. So you decide to put the letter inside a locked box. You lock it with a special key. Now, even if someone steals the box, they cannot read the letter. This locked box is encryption. The key is the decryption key, and the thieves on the road are hackers, attackers, and cybercriminals. Encryption makes your data useless to anyone who doesn't have the key. Why encryption exists? The real reason. The internet was never designed for security. It was designed for sharing information, not protecting it. In the early days, everything was sent in plain text. Passwords, messages, bank details, everything. Hackers didn't need to hack, they just needed to listen. Encryption was created to fix this fundamental flaw. It became the seatbelt of the internet, the helmet of digital life, the lock on every online door. Real-world example, WhatsApp. When you send a message on WhatsApp, it doesn't go like this. You, WhatsApp server, friend. Instead, it goes like this. You, encryption, encrypted message, decryption, friend. WhatsApp cannot read your message. Your internet provider cannot read your message. Even the government cannot read it unless they break the encryption, which is practically impossible with modern algorithms. This is called end-to-end encryption, E2EE. Why encryption matters today, 2026 reality. Every second around the world, 3.4 million emails are sent, 1.2 million WhatsApp messages are delivered, 90,000 online payments are made, 40,000 files are uploaded to cloud storage. Without encryption, all of this would be exposed like a diary left open in a public park. Encryption is not a luxury. It is the foundation of digital trust. There are 2 major types of encryption, symmetric encryption and asymmetric encryption. Let's break them down with simple analogies to help understand how each type works in the real world. Imagine a box with a single key. You lock the box with that key. Your friend unlocks the box with the same key. This is symmetric encryption. One key for both locking and unlocking, shared between sender and receiver. When you zip a file with a password, that's symmetric encryption. The same password locks and unlocks the file. This is a common example of symmetric encryption in real life. Symmetric encryption is used in hard drive encryption, Wi-Fi encryption, database encryption, file encryption, and cloud storage encryption. It's widely used to keep data safe in many everyday technologies. Famous symmetric encryption algorithms include AES, Advanced Encryption Standard, the gold standard, DES, old, insecure, and 3DES, better than DES, but now outdated. AES is so strong that even supercomputers would need billions of years to break it. Now imagine a box with 2 keys. One key locks the box and a different key unlocks it. This is asymmetric encryption. It uses two separate keys for security. You share your public key with the world. Anyone can use it to lock a message for you, but only you can unlock it using your private key. This system is at the heart of secure communication. When you visit a website with HTTPS, your browser gets the website's public key. It encrypts your data, and only the website can decrypt it using its private key. This is how secure browsing works. Famous algorithms for asymmetric encryption include RSA, ECC, elliptic curve cryptography, and Diffie-Hellman. These algorithms help in securing online communications and transactions. Symmetric encryption is fast but requires sharing the key. Asymmetric encryption is secure but slow, so modern systems combine them. Asymmetric encryption is used to exchange keys. Symmetric encryption is used to encrypt data. This hybrid model powers HTTPS, banking apps, VPNs, cloud services, and messaging apps. Encryption keeps our information safe across many modern applications and platforms. Imagine two people, Alice and Bob. Alice wants to send Bob a secret message. Step 1. Bob sends Alice a key that can only lock messages. Step 2. Alice uses Bob's public key to lock the message. Step 3. Bob uses his private key to unlock it. Even as the hacker intercepts the message, they cannot unlock it. This is the magic of asymmetric encryption and how it keeps secrets safe. Case Study 1. The 2013 Yahoo breach. Yahoo stored user passwords without proper encryption. Hackers stole 3 billion accounts. It became the largest data breach in history. If Yahoo had used modern encryption and hashing, the damage would have been far smaller. Case Study 2. The WhatsApp Pegasus attack. Pegasus spyware tried to break into WhatsApp, but because WhatsApp uses end-to-end encryption, attackers could not read messages. The attack targeted phones, not the encryption. This proves how strong E2EE is. Case Study 3. Ransomware encryption. Ransomware encrypts your files and demands money for the key. This is encryption used for evil, but the principle is the same. Without the key, the data is useless. Case Study 4. Apple versus FBI, 2016. The FBI wanted Apple to unlock an iPhone. Apple refused because breaking encryption for one phone would break it for everyone. This case showed the world how encryption protects privacy. Tools used for encryption. Beginner-friendly. For individuals, BitLocker encrypts your laptop. Veracrypt encrypts files and drives. NordVPN, ExpressVPN, encrypts internet traffic. Signal, WhatsApp, encrypted messaging. ProtonMail, encrypted email. For companies, TLS SSL certificates, AWS KMS, Key Management Service, Azure Key Vault, Google Cloud KMS, HashiCorp Vault. Frameworks and standards. AES 256, strongest widely used encryption. RSA 2048, RSA 4096, secure public key encryption. TLS 1.3, modern secure communication. FIPS 142, government encryption standard. ISO 2701, security management framework. How companies should implement encryption, step by step. 1. Encrypts data at rest. This means encrypting data stored on hard drives, databases, cloud storage, backups. 2. Encrypt data in transit. This means encrypting data moving across networks, HTTPS, VPN, secure APIs, encrypted emails. 3. Use strong key management. Keys must be stored securely, rotated regularly, never hard-coded in code, never shared over email. 4. Use end-to-end encryption for sensitive data, especially for messaging, financial transactions, healthcare data. Mistake 1. Using weak passwords. Even the strongest encryption fails if the password is 123456. Mistake 2. Storing keys in plain text. Developers sometimes store encryption keys in GitHub, code, email, shared folders. This is like leaving your house key under the doormat. Mistake 3. Using outdated algorithms. DES, MD5, and SHA-1 are broken. Using them is like locking your door with a toy lock. Mistake 4. Not encrypting backups. Hackers often target backups because companies forget to encrypt them. Mistake 5. Believing encryption alone is enough. Encryption protects data, not systems. You still need firewalls, EDR, MFA, zero trust, monitoring. For learners, use a password manager. Enable 2FA everywhere. Use encrypted apps. Learn AES, RSA, and TLS basics. Practice with tools like Veracrypt. For companies, enforce encryption policies. Use cloud KMS solutions. Train employees. Audit encryption regularly. Implement zero trust. Quantum computing threat. Quantum computers may break RSA in the future. This is why the world is moving toward post-quantum cryptography, PQC. AI-driven encryption. AI will help detect weak encryption, automate key rotation, predict attacks, strengthen algorithms. Homomorphic encryption allows data to be processed without decrypting it. This technology is set to revolutionize industries such as healthcare, finance, and cloud computing by keeping sensitive information safe during processing. Encryption is not just math. It is not just technology. It is the shield that protects your identity, your money, your privacy, your conversations, your memories, your business, and your future. Every message you send, every payment you make, every file you upload, every login you perform is protected by invisible walls of secret code. Encryption is the silent hero of the digital world, and now you understand it. If you want to master cybersecurity in a way that is simple, visual, and unforgettable, if you want to understand the digital world that protects you every single day, if you want more modules like this, explained with clarity and real-world storytelling, then hit subscribe, tap like, and follow Knowitrix, where complex technology becomes simple knowledge.